galaxies, you'll notice a distinct spiral arm structure from the rotation of the galaxy itself. Well, the thing you need to realize about this rotation is that the inner stars actually rotate faster than the outer ones, which begs the question, why are there still spiral arms if the galaxies are millions of years old? Because just within a couple rotations,
based on the speed of rotation, which is about 168 miles per second, it should take about 200 million years for a galaxy to complete one rotation. And the fact that there's spirals at all is because of that rotation.
they should be spread out by now. We talked about a couple weeks ago how we haven't actually seen a star form, the actual formation, the actual nebula hypothesis where the cloud breaks down and collapses on itself. We don't see them form, but we see them blow up about every 30 years.
We do actually see galactic clouds, stellar nurseries forming right now. They're called cosmic eggs, EGG.
Blue stars are a problem for old Earth people because blue stars burn really, really, really hot, really intensely. That's why they're blue. And they should not last that long. The problem for the...
Yeah, not all stars are the same age, and large stars like red dwarfs, like red giants, burn faster than small stars like red dwarfs. Also, he keeps calling stuff evolutionary. Cosmic stuff doesn't have anything to do with evolution.
And then the issue of solar wind and solar drag. Now with solar wind, here's what happens. The sun's radiation applies an outward force. So what should happen is tiny particles that are in our solar system, in particular tiny particles that are around the sun, should be blown out away from the sun and out of our solar system.
Solar pressure is incredibly small, and it rapidly diminishes the further out you go in the solar system. Solar sails work on this, and they can't really function that well past a certain point.
I do want to touch on this fairly quickly. How many of you have ever heard the argument that since we can see light from stars that are billions of light years away, that proves that we're billions of years old? Who's heard that? Okay, a few of you. It's kind of, what I want you to notice is you have the same assumptions in that dating method as you do with radioisotope dating and any other dating method. Here's the argument. There are some stars that are really far away. Let's say 5 billion light years away. And a light year is a distance. It's essentially how far light will travel within a year. So if a star is 5 billion light years away, that means light, even traveling at the amazing speed of 186,000 miles per second, would take 5 billion years to get from that star to the Earth. And the simple argument goes, well, if we can see light from that star, and that star is 5 billion light years away, then we must have existed for at least 5 billion years for the light to get here. Pretty straightforward. But I want you again, and we've seen this a couple of times, but notice the unspoken assumptions behind what they just did. First,
the speed of light doesn't change. That would violate the theory of relativity.
It's kind of cool. Then you got this. Planets are cooling down, which makes sense. Things like Jupiter. Jupiter loses twice as much heat as it gains from the sun. Now here's the problem. It doesn't generate heat by itself. It has a limited amount. Second law of thermodynamics, things run out over time. It's just what happens.
Jupiter generates heat through pressure and radioactive decay, and the second law of thermodynamics only applies to a closed system.
Neptune is still very warm. Not only Neptune, but then Saturn, Uranus, Venus, they are all way too hot to be billions of years old.
Venus is actually hotter than Mercury due to the greenhouse effect. It gets all of its heat from the sun.
Issue with Jupiter's moon Io. It is extremely hot, has extremely active volcanoes shooting huge plumes into the atmosphere. According to the evolutionary model, it should be stone cold. Jupiter's moon Ganymede.
Io is the innermost of the 4 Galilean moons. It's affected by tidal heating, which is gravitational forces applied by Jupiter and the other 3 Galilean moons. The Galilean moons orbit in a resonance, so it applies a lot of force onto Io especially, but also Europa, Ganymede, and to a lesser extent Callisto.
Ganymede has a really strong magnetic field, which implies a liquid core. And again, if it was billions of years old, it should be stone out the size of the sun. It's huge. And the thing is, if it was actually billions of years old, it should be very weak by now. It's pretty much non-existent.
Magnetic fields vary, and Jupiter has enough mass to keep a magnetic field for a long period of time. Mars, for example, didn't. It lost its magnetic field fairly early on. Well, that just shows how little they understand about cosmology and astronomy. And the way they keep calling everything evolutionary is really weird because it has nothing to do with biological evolution.